My name is Eric Ritchie with the Customer Engagement Team here at Autodesk. Today we're going to be talking about laser scanning versus photogrammetry for building exteriors. Which is really the right way to go? Is there a better option, etc. So with us today we have Dominique and Dennis. They're going to be helping to run us through a project they did, doing some comparisons. As always with these sessions, if you want to ask questions, you have your GoToWebinar widget. Feel free to type your question right there in the question box, and we'll answer as many as we can at the end, given the time. Also, you'll see that we are recording today's session. We'll be posting that on YouTube probably within the next week. As always, if you have feedback for us, reach out to recap.community@autodesk.com. If you have ideas for additional sessions, maybe something you'd be interested in presenting, or just general feedback for us, we'd love to hear from you. With that, I think I will hand it over to Dominique. Good morning, Dominique.
Oh, hi. Thank you, Eric. I'm Dominique from the Reality Solutions Group in Autodesk as well. So what we're going to speak about today is very interesting. It's about comparing laser scanning with photogrammetry. Basically, this is a test we did about a few weeks ago in Atlanta, thanks to Repro Products on GeoSurvey. A very interesting test that we put in place in order to document how we could best use laser scanning and photogrammetry together using survey points, but also what kind of results would we get if we compare laser scanning with photo-based models. We also use two different UAVs, so you will see the difference you get in quality on quantity about these kind of devices. So a pretty interesting topic, hopefully, today. Just want to start by saying thank you to Repro Products that allow us to fly on top of their building, their office space in Atlanta. Zoltan was in charge of laser scanning as well as been spending time with us. And also thank you to GeoSurvey, Trenton and Brad, that show up in order to survey your site and give us very accurate survey data using their total station. And of course, the team of Autodesk, Shan flying his own UAV, Mike as well, Dennis that has been doing all the comparisons on myself. So the site we flew is a typical office space, a commercial building in Atlanta. Just to give you an idea of the site, on the size of the building, this is a video that was shot using the Inspire 1 UAV. You can see here Zoltan scanning the rooftop with his Faro scanner. So you see the kind of size we are dealing with. Pretty big building. Just another view as well. This is Mike and I flying Mike's UAV around the building. So you see the kind of, and this has been shot from the Inspire, so second UAV. So you see the kind of site we are dealing with today. Okay. So let's speak about laser scanning first. So the entire exterior of the building has been laser scanned using a Faro X330, which is one of the latest Faro scanners. There's been 34 scans. We'll show you the result in a minute. Also, there's been 12 survey points collected through using a Trimble SI on their station TSC3. All this was then registered inside Recap 360 Ultimate. So I will pass it to Eric that will show you the result inside Recap 360.
Sure. So as you can see here, we have pretty standard point cloud here. You can see that you can tell by the kind of shadows here, if you will, the holes. We actually did crop these cars out, to remove some noise since there were vehicles pulling in and out during the scan. But as you can see, it's pretty nice looking point cloud. Pretty typical for what you'd see from this. We'll show you. We do have our our real view imagery as well. Again, pretty standard for most of these projects. Just I'll try not to move around too quickly just because of the session. But as you can see, we have some pretty nice looking data here.
So just a few additional words. So I think it took Zoltan, to be fair, on the GeoSurvey team about 3 to 4 hours to collect these scans, and probably the same time to register that. So we are speaking of, say, less than about a day job here altogether for these laser scans. Okay, so this is what we wanted to show about laser scans. So this will be use our ground truth base for comparing to the photo-based models. So how do we do in terms of accuracy? Let me switch back to the slideshow. So these are the 12 survey points that we measured, and we compare the laser points to the survey points. So this is a typical, say, accuracy that you can get from a laser scanning. I'll say in this case, this is an exterior of the building.
Yeah, I mean, you can see here that the error is pretty low on everything. These points all look pretty good from the survey, but in general, pretty low average error here.
All right. So this is what we wanted to say about these laser scans. So this is again the ground truth that we will be using now to compare to photo-based models. So for the photo to 3D aspect, we use 2 drones. One is a commercial drone. It's a DJI Inspire 1. It's one of the most successful prosumer device. Price is around $3,500. So let's say $4,000 with suitcase and everything. It comes with a 12 megapixel sensor, which is a rolling shutter sensor. It is a rectilinear lens. It's not a fisheye lens. So which is pretty good, so we don't have to defish those pictures. So we flew this guy, and we collected about 160 photos. You will see a kind of quality we get from that, and you will see what was the flight path we used for the DJI. We also use, I call it Mike's drones. Mike is one of our colleagues, Mike Gemmel in Autodesk. He has built his own UAV in order to be able to fly a Sony A7R, which is a really good camera that comes with a global shutter, 24 megapixel sensor. And we also, by chance, collected the same amount of photos, but that was not an objective. And we process all those on Recap 360, of course. So let me show you first the result we get with the Sony, which is really the best camera in this case, and then we'll discuss how we did that and what was the flight path, something like that. So looking at the result, I will be using our latest Memento software, which has a strange behavior here. Let me restart it.
Yeah, we have had, with the GoToWebinar, we have seen in the past some artifacts and stuff. So it's I don't think it's actually Memento where you've just
anyway.
the magic of live demos.
It's coming back here. So Memento is our mesh-based tool for photo to 3D plus other sensors as well. But this is a really nice tool for editing your mesh, cleaning up, healing your mesh, and preparing that for 3D publishing on the web or 3D printing as well. So here is my 3D model coming back. And this is again the data set of the source photo were the Sony photos. And you see it's really a good quality 3D model. I'm trying not to go too fast so that we have a refresh rate which is acceptable. Yeah, I see. So you see the quality of the model that we got from this Sony device mounted on my UAV. It's really, really good. If I get closer to the building, if I switch to surfacic mode, you will see that we have a very flat surface on the roof, which is something which is really impressive given that the roof is pretty uniform. If we look at the edges as well, let me show you the edges with the wireframe mode. And get closer to this angle, for example. You see that the edges are pretty straight. And this is, I would say, one of the best photo-based models I've ever seen over the last years. So definitely a very good photo-based model that we got from the Sony device here. And then we'll show you what was the flight path we used in this case, okay? Now let's go back to the photo texture mode. Let's zoom, or let's move around this building so that you can see all sides of it. You see on this wall here, you see the survey targets that were used for laser scanning on photogrammetry. Here you see the other side of the building. You see, this is really a good quality model again. I'm really impressed. And I can tell you I've seen many photo-based models. Even the cars on the parking lot are really well modeled. So this is the quality we get and we got from the Sony device. Let me show you now the quality we got with Inspire UAVs. They're pretty good, but not the exact same quality. Again, I'm using Memento to show the result. Zooming in, you see the building coming. So it's still a very decent 3D model. Definitely, if you would show that like 1 year ago, say, oh my God, this is amazing. But then comparing to the Sony, let me show you the big difference. The big difference is really about the surfaces on the, look at these edges. So you see, it's not as straight as we got from the Sony camera, definitely not. So say, pretty good model, but for engineering work, I would say this is the lower limit. Okay, and again, this is a rectilinear lens. This is not a GoPro. This is not a fisheye lens. You will get even worse results with a GoPro. So, how did we do that? For the Inspire one, so the Inspire one, we use two rows of of photos. The first row was about the same height than the building, and the second row was a little higher in altitude. And each row was made of about 80 photos each. So remember that if you want to do a good job with photogrammetry, you have to take at least one photo every 5-10 degrees, but 5 is better. So that takes you around 70 to 80 photos for each row. And be careful to have always a good continuity, particularly in the angles of the building. For Mike's drone, Mike's UAV with the Sony camera, we did differently. We use one row of photos first, and then we use say rectangular patterns. So in fact, each facade was then shot with rectangular patterns. So we had 4 rectangular patterns for each one of the 4 facades. That's another strategy. It's a little longer, but looks like it's also giving better results, at least in the case of buildings, of course. If you need to fly, let's say stockpile or mine, you will have to adapt your flight path. We can definitely document this. Another very important aspect, of course, is that you need to import the survey points, the stitching process. So we use the same survey points that we use for, comparing the laser scan to the ground truth data. So we use the same survey points in the stitching process, and that you can do using the ReCap 360 or the Photo and ReCap 360 web service. What you do is that you match these survey points on at least 4 to 5 pictures, and then you enter the XYZ coordinates corresponding to this target. So having said that, you've seen the laser scan, you have seen the photo-based model. How do we compare now? So
you want me to talk about this?
Yeah.
Okay. Thanks, Dominique. This is Dennis. So I did the comparisons between the LiDAR and the photo model, and we used a free software called Cloud Compare that you can compare 2 meshes together or 2 point clouds or a point cloud to a mesh. It also has some other handy tools like a point cloud to point cloud registration. So we use those to generate some visual, what we wanted to get, when you register and you get a list of points or errors when you do LiDAR, we wanted to get something more visual we could look at and see which surfaces were close and which ones were far apart. Sorry?
We just aligned the 2 automatically.
Okay. So we did the first data set we compared is the photo to laser, and we compared the Sony A7R data set with the survey points and the laser scans. So what we're looking at here is a scale from 0 to 6 inches. So blue being 0, so blue is the best, blue, green, yellow, and red is 6 inches. And those colors are mapped to the point cloud from the photos. So what you see here, the red areas are actually the cars, for instance, are in the photo data, but not in the LiDAR data. So those were cleaned up as we saw earlier when we showed that. And one of the reasons we're talking about using UAS to augment your LiDAR data is a lot of times when you're LiDAR scanning, you're stuck on the ground and you're missing the tops of everything. So one use is merely to fill in the gaps that you didn't get with your LiDAR scanner. So you can see these surfaces in red are the tops of things. In this case, we were lucky enough to be able to get on the roof of this building. Quite often, you would walk around a building and you never get on top of the roof. So you could fill in that data, basically, with the data from the UAV. So that's what those surfaces are. So in order to do a comparison where what we really wanted to do was compare the surfaces that were captured with both techniques only. So what we've done here is we've thrown out all the points that were over 4 inches error. So the cars are thrown out and the tops are thrown out since they weren't captured with the LiDAR. And we mapped the error on that, and what we get here is a curve. If you look to the right of where it says repartition, you'll see a curve showing where the points lie on the different scale. And zoom in there, and so you're going to see we're right around 11, 12 millimeters overall. And you can see some areas, you'll see by the entryway, it's green. So again here, blue is our 0, and green is a little bit higher. So the entryway is a little greener, and that's because, I believe that's because the surfaces are shiny. So just like LiDAR can bounce off a shiny surface, but also for photos, a shiny or reflective surface will, the shiny reflective surface will cause problems with stitching.
So we can say that on average, in this case, using a good camera, using a good flight path, using survey points as well, comparing the photo-based point cloud to the laser-based point cloud, we are within an average of 43 inches everywhere.
Right, I'm glad you point that out, because one important thing to say here is, as Dominique showed earlier, before we uploaded the photos to recap photo to make this model, we did put the survey data into this. So that data was used while it made the model, which improves the accuracy, as we're going to see, because we're going to look at the version we did without those survey points next. So that's what we're going to look at now. Is we did the exact same set of photos, and we just did not add the survey points to it. And let's see what that comes out like. The same one?
Yeah, on the left we have the same than before, which is
okay. Yeah, so the left is what we just looked at, and then the right is the photos with no survey data used to create the model. And you're going to see it's a lot greener, so the error is a bit higher, and you'll see the curve is a bit longer. So it's not as accurate. And you'll also see, again, the reflective areas on those surfaces at the front are quite a bit worse than the brick wall next to it, which is more diffuse texture, is all blue.
All right, so I think this is a very interesting use case from which we can draw a few conclusions. So basically, we knew that, of course, from a long time, but this is to prove that the better the camera, the better the results, of course, okay? Sometimes we used to say garbage in, garbage out, okay? So we also show that using survey points in the stitching process makes the photo to 3D data much more accurate. But having said that, with a good camera, a good flight path, those survey points, definitely we can expect good 3D data much below 1 inch. We are average between less than 0.5 inch, in fact, in this particular case. But the idea is not to oppose laser scan with photos. The idea is more to find complementarity between the laser scans on the photogrammetry technology. Since we have this alignment using the same survey points, mixing the two data sets is now very relevant. So what would be the use cases for doing such laser and photo workflow together? I would say typically one is, as Dennis said, is to append your laser scan with the beyond line of sight filling. So typically in this case, of course, we laser scan the rooftop, but this is not that often that we can access the rooftop with laser scan. So if you don't access the rooftop, this is what you would get from laser scan. So everything which is within the line of sight of the parking. And then if you add the photo-based model, then you can append your laser scan with a good quality data. So this is a scans and photos. So again, coming back to scans only, and then switching to photos and scans, okay? This is a typical use case, and we are definitely very interested in those, use cases. Another use case is also to add the context. So, for example, this has been laser scan, so everything here is from laser scans only. And then if you have the photo-based context, then you add a lot of value to your data set. Okay, so this is a typical workflows where mixing, say, UAV data, so photo-based data with laser scanning make a lot of sense. Definitely we will be moving forward on those use cases. Okay, so this is what we wanted to show you today. I will pass it to Eric now for the conclusions of the rest.
Sure. Thank you, Dominique, and thank you, Dennis. So, as you guys can see here, we have, if you're looking for more information on Recap or Memento, you can check out the website. Of course, the YouTube channel where this video will be posted. We're on Twitter, we're on Google+, et cetera, et cetera. And again, let me point out, feel free to reach out to us at that recap.community@autodesk.com email address. Send us feedback. We'd love to hear from you. And so with that, I think we have a few moments. If anybody has some questions for us, feel free to, as I mentioned at the beginning, type those in to the question widget. So let's start off with. It was pointed out to us that I guess there was a mistake on one of the slides. We said that the Sony Alpha A7R was 24 megapixels. It's actually 36 megapixels.
Okay. My mistake.
So even better.
Okay.
So, you know, really, there's a question about, so, you know, can I do my project with just, you know, just photos and get the exact same quality as I can with a laser? You know, can I replace my laser workflow with photos?
This is a really good question. Again, this is not about opposing the two technologies. Definitely nothing will replace laser scanning when it comes to having survey-grade data that you can trust, that you can use for your own customers. This is more about either appending your laser scan. You may use photo-based model for conceptual modeling, definitely, or there are many other use cases, like, for example, measuring the volume of a stockpile, okay, or measuring the earth that has been removed from an excavation site, okay. In this case, yes, I think a photo is good enough. You don't need to laser scan those anymore. But for everything around buildings, construction sites, something like that, for survey-grade engineering work, I think laser scanning is still the solution. When it comes to monitoring the site daily, when it comes to conceptual modeling, or again, those volumetric measurements or some linear measurements, yes, so photos from UAVs, because gives you the perspective that you need, is definitely the way to go.
Okay, so now we're getting a few more. So we mentioned that we use 12 survey points on this project.
Yeah.
The question is there a good rule of thumb for how many survey points you should include in a project?
Well, I would say that this is close to the minimum for a building this size. Most important is that those points are spread out along the building. And I'll also point out, in addition to having a survey, if you don't have a survey, what you want to do is you're going to want to take one very long measurement, or maybe a couple to be safe, and using that one measurement, say, in this case, the width of the building, something very long that you know you can measure point to point very accurately. And you can use, instead of using survey, you can use that one measurement to scale your whole site. Because when you just upload photos, there will be no scale, no correct scale associated with the model you get back unless you put in some survey control or a measurement. So I would say the 12 points we had was a good amount. I mean, the absolute minimum is 3, of course, to have a fit, but you would want, I would say around 12 is reasonable for a building this size.
Okay. So what was approximately the total time taken to both fly and survey the site?
Well, I can tell you because I was there. So again, laser scanning took about 4 hours, 3 to 4 hours. On the flying the two UAVs is about say, for the Inspire one, we just did these 2 rows of photos, and it was something like 30 minutes. For the Mice UAV, it was a little more because we did these regular patterns or rectangular patterns in front of each facade, but less than 40 minutes. Of course, then you need to arrive on the site. You need to so altogether for the UAVs, we spend like 2 hours on site.
Okay, great. You know, another question, we don't really have time to get into it in detail, but we do have another session that shows it on our YouTube channel. The question is about combining this laser scan data with the photo model, setting those survey points. As I said, we do have a session on our YouTube channel walking you through that whole process. You know, we can definitely point you to that again, but you know, we don't really have time to get through the whole process. But it's in general, you're picking some common points in your photos that show the survey points. You're adding your XYZ coordinates, and then when you bring your point cloud generated from those photos into Recap, they will be aligned with your survey data.
That was a process that is used in Cloud Compare as well. So we didn't have to manually align the two. They are automatically aligned because they use the same survey point.
Exactly.
All right, so unfortunately, I think we're about out of time. We have a few more questions that came in that, we'll try to follow up with later. But, thank you, everybody, for joining us, and we hope to see you next time. Thanks, guys.
Thank you.